Now, this idea of the component of vector can also be used to find the length of the vector. So if the vector is 3 units in the x direction and 2 units in the y direction, and we know this is 90 degrees, so we can use Pythagoras theorem to find the length of the vector CD or the vector AB, which is written as magnitude of vector CD will be square root of 3 squared plus 2 squared, and that's square root of 9 plus 4, which is square root 13. In general, if we have a vector PQ, which is x units in the x direction and y units in the y direction, then the magnitude of PQ can be found using the Pythagoras theorem as square root of x squared plus y squared. And this is true for every vector that there is. Let us now draw another vector. So I'm going to draw a vector maybe from -2 to say -7. And going from 1 to 3. So say this vector is EF. Now, in order to go from E to F, we have to go from -2 to -7. That means we are going in the negative x direction, 5 units. So this is -5. And we have to go up by 2 units. So this is +2. So what is our vector EF? The vector EF is -5 and +2. And it can also be written as -5i plus 2j. So what will be the magnitude of the vector EF? Making use of the Pythagoras theorem, square root of -5 square plus 2 square, actually -5 is not even necessary, is equal to square root 29. Now let's recall again, what was our vector AB or CD? The vector AB was 3, 2, and the vector EF is -5, 2. Adding vector when it is written in column vector form, or when it is written in terms of the unit vector I and j, is very easy. If I want to add these vectors now, AB and EF, what we simply do is we add the x with the x and the y with the y. So 3 plus -5 will be -2, and 2 plus 2 is 4. Which means that if I want to go from A to F, I have to add the vector 3, 2 with -5, 2, and I'll get -2, 4. That's the vector AB plus EF.